on the maximum demand, again, see, this is your maximum demand, 8 MA or whatever it is, that is your maximum demand. Again, you need to look at one more factor called, right? What is that? That is losses. What do you mean by losses? Losses in transformer and losses within the transformer plus losses in the entire whatever that equipment it is there, maybe cable, right? You need to include both actually. So see, when you look at the losses, no, let's try to look at the losses. We can also see the losses, right? See, you see here. So 8370, no, for easiness, if you look at, you need to add this actually, right? So let's try to do that quickly so that you can understand that how the transformer size is calculated. So here the kilowatt from here you are getting is 6802. Here you are looking at no something, right? So 6802 plus the active power loss because of that, transformer resistance, right? So 44.8. So that means 44.8. So when you sum it, you will get, you see that 6847 you're getting, right? Similarly for the KVR also, you need to look at two important things, right? Don't only concentrate on active power, you need to look at the reactive power. Both are important, right? So here you see 4215, then here reactive power, you see that 581.9. when you sum it, no, so 4797. So here itself we can come to know that when you are sizing the transformer, you should not only consider your load, you need to consider the transformer loss as well as the cable loss, which maybe cable I have not put it here. When I put a cable, that also additionally adds up. Okay, so the fundamentally this you may not be able to visualize while doing the work. Maybe since we have the software, you can easily, like, the calculation part is very simplified, right? Yeah, 48.8 is transformer internal loss, which means due to the copper loss, right? Due to the copper loss. See, this value is impacting it. You get my point, right? The another why this is very high, this one, percentage of X, that is because of the your reactance. You are getting the reactive power, right? So these two values, that is why it is coming out. Okay, that's why your transformer. Now you see that when I increase the transformer, please note down. Now for the simplicity, let me put 10 MVA now. Okay, let's run it. Let's run it. Generally, you see that why it is showing in red color? Because your transformer is exceeding its capacity. So what we are capable is 10. What you are looking at is the 10.5. That means while sizing the transformer, you should not only look for the load, you also add the, what is that called? You also should add the losses in that. So that also you need to consider it. Not only this, you also need to add the losses in transformer and losses in cable. In that, typically while designing itself, you may not be able to find out. So you have to consider, like, typically 3%, or when you are starting with a scratch, you have to consider 3%. But once you develop the single line diagram, etc., length and everything is no, then this percentage can be optimized, right? Maybe it may become 2%, or maybe typically the losses within, it will come within, 1 or 2%. That's it. Within 3%, maximum it would not go, because too much loss, too much. I mean, the energy is waste. So people, they don't like to waste the things, energy, right? So too much loss also not good for. What is the minimum loss that we can achieve? That's what you need to look at. So that is why in renewable companies and solar companies, they will be very concerned about these losses actually, right? It has to be minimized as